Okay, this is a Miro, the digital whiteboard which I'll be using. And as I said earlier, I've uploaded the link to this whiteboard in the chat box. You can use the link to access this whiteboard for the rest of the semester. Okay, guys, just a very quick recap since last week. So, right. So anyway, basically are in this chapter called organic chemistry, and there is what we call a family. So the official name or the scientific name will be known as homologous series. So make sure you know this, the meaning of this term, homologous series. Okay, so what are the homologous series or families of chemical substances we need to know? There are actually a few. Of course, in real life, you're expecting to see a lot more than just what we are doing right now. Okay, let's get somebody to answer. Sanchi.
Yes.
Yes, tell me, give me one homologous series.
Alkene.
Okay, good. Now, of course, once you know the homologous series, you are supposed to know the functional group of that particular homologous series. Basically, functional group defines that series. So whichever substance that has this particular functional group is counted as part of that series or that family. So, Zhang Qi, for the alkanes, what is the functional group?
Functional group. Like
Yep.
what?
Do you
Like
know
what?
what's functional group?
Is it a formula or is it a methane? Something like that.
Is the characteristic of that family.
Oh,
Hmm.
I don't know.
Okay, guys, you're supposed to know this, even though it's not officially in your syllabus because it's from N levels. Now, officially, alkanes have no functional group. However, you need to know that they all contain only carbon and hydrogen. And they only have single bonds. Oh yeah, guys, I didn't remind you. I hope you have your notes somewhere handy around you. Yeah, because you're expected to write down things. Okay, so scientifically or officially, the alkanes do not have any functional group, but you have to at least be able to identify alkanes. They contain only carbon and hydrogen with only single bonds. Okay, how about another functional group? What else do we or what else are you supposed to know, Nigel?
Yes,
Nigel, give me another homologous series.
alkenes.
And what's the functional group?
Um,
What is characteristic of alkenes? They have.
En,
Mhm.
uh, H2N.
Now that is known as the general formula, but you still need to answer what is the functional group of alkenes. What is inside an alkene that makes it an alkene?
Double bond.
Yes, that will be the answer. Now, guys, can you be a bit specific? Make sure you write C double bond C. As I said before, there are other kinds of double bonds. You have C double bond O, C triple bond. Okay, maybe this not counted. This is a triple bond, but it can easily be a C double bond N as well. Okay, so to be specific, I'm referring to this one, C double bond C for alkenes. Ernest, give me another homologous series.
Alcohols.
Okay, this is right from your syllabus, alcohols. Ernest, functional group.
The hydroxyl group.
Okay. Yes, guys, you're supposed to recognize this OH group. And of course, you need to know the name. which Ernest provided, so it's called the hydroxy group. Reason is, in your test and exam, the question may simply use the word hydroxy group, and you're supposed to know that it is OH, and of course it is the group for an alcohol. Now, next one. Edison, give me another homologous series.
Carboxylic acids.
Okay, good. And the functional group? Yeah, Edison?
Not sure, because last time you didn't. I don't think you go through it.
Oh, I didn't. Okay. Come, guys. Okay. If you have your notes around you, make sure you write this down. Basically, they have this particular thing. All right. This is, of course, in your syllabus. You need to recognize it. And there's a name as well, which you need to know is the carboxy group. Now, I believe I've done something like this before. Also, be very careful. You can obviously draw it in various ways. Yeah, this is fine too. This is exactly the same. All right, even if you draw like this, it's perfectly fine. It's still the same. And of course, even if you draw like this, it is still the same. Okay, so be very flexible when you handle this sort of structures. Now, occasionally people write in this manner. Again, it's still the same. So guys, I especially want you to recognize this because this comes up quite often. So make sure you realize that it's a carboxylic acid or carboxy group. Okay, questions anyone? If you do, just voice up. But of course, you can use your chat box, even though I may not look at the chat box that much. Okay, that is carboxylic acids. All right. What other function or what other homologous series is in your syllabus? Shonen? Where's Shonen? Shonen, are you there? Oh, microphone is not working too. Okay, same thing. I'm going to record all your names down. Make sure you get it fixed up the next round. Well, Shonen, you can type it out in the chat box. Do you know of any other homologous series? Okay, so well, it's okay. You can remember, but make sure you jot it down. Okay, guys, come. If you can't remember, jot down this one because this is in your syllabus too. Okay, there's one second last one, esters. How do you recognize esters? This okay, look for this structure. This is the ester group, but more often than not, they don't call it ester group, they call it an ester linkage, which all you guys need to know the term ester linkage. But I want everyone to be careful. You may want to pay attention here. Can you guys compare these two? Look at them. What's the difference between this? Yep.
Got the OH and then got the O connected to the carbon.
Okay, good. So guys, be careful. This part here is a carbon. Okay, it's not a H. But most of the time, in fact, I would say all the time, they don't even draw the carbon up. But you're expected to know this there's a carbon over here. It cannot be a H. If it's a H, then it becomes a carboxylic acid. So guys, please be very careful between these two. One more thing. Look at my alcohol again. Alcohol, yeah, you see your hydroxy group OH. Guess what? You see a hydroxy group here too. But guys, I'll make it very clear. I probably repeat in class again, but guys, might as well get it right the first time. If you ever see this chunk here in your exam or test, immediately you should know it's a carboxylic acid. Do not call this a hydroxy group. Okay, this one here. Not call this a hydroxy group. Reason, it has, let me change the color. Reason, it has these neighbors around it. This neighbor, all right, C double bond O, it has this neighbor next to OH. So do not call this a hydroxy group. It has come up quite a few times. So please remember. I mean, of course, I'll try to revise it, but I may just, hopefully I can remember that. So do not call this a hydroxy group if it has these two neighbors. Once you see these two neighbors, the whole chunk is called a carboxy group or carboxylic acid group. Okay, can guys? As I said, this has come up quite a few times, so don't make a mistake. Once don't just see OH and then immediately you call it a hydroxy group. It is not, because of these two neighbors nearby. Questions, anyone? No? Okay, then let's go on. The message. Let me see. Somebody sent a message for
Yeah.
Yep.
Ziming not inside the MS Teams.
Okay, I see. That's him. Okay, I'll let him come in. Okay, yeah, he should be able to join now. Okay, let's go on. Now, okay, let's look at our homologous series again. So far, we have 5 of them. 1 and 2 are covered in your N levels, but well, I of course revise them a bit over here. 3 and 4 and 5 are in your current PFP syllabus. There is one last group. Technically it's not homologous series, but it's quite important in your test and exam because it comes up every time. I would say every time. Okay, the last group, technically not homologous series, but I include it in for you to be aware of them. They're called polymers. What's the functional group? Well, it has, basically they have different possible groups. Okay, of course by groups I refer to functional groups. It depends. We'll go into this in more detail later on, but just keep in mind that it has no fixed functional group. So what are polymers? I'll just give you a very short description of polymers. So basically polymers are very big molecules. Okay, let me rephrase it. Instead of using big, I would say they are very long molecules. Okay, that would be the precise word. They are very long. You're talking about thousands up to millions of atoms long. So that is the kind of length you're looking at. They are very long molecules. And of course, since they have different possible groups, so there are quite a few types.
Sure, you're muted, you're muted. Okay.
Um, okay, guys. Anything you need me to repeat? No. Okay.
What you said, I didn't hear you say the only need to know two types, that part. How do you muted yourself, Cha?
Yeah, let's go back to the polymers part. So as I said, number 6 is polymers. And they do not have a fixed functional group. They have, depending on the type, they have different possible functional groups. Right? Of course, in the real world, you have a few types. However, for your syllabus, you only need to know 2 types. I will not touch on them now. We'll cover them later on, just before your test. But P polymers are covered in your MST. Now, the other point that I want to make is polymers are basically very long molecules. Okay, very long. They are talking about thousands to millions of atoms long. Okay, so yep, I think that's all I have to say about them right now. All right, yep. Any questions from anyone? No. Okay. So now, the other thing I want you guys to be aware of, especially in case you haven't realized by now, basically the things that I cover are important. Okay, I don't cover filler stuff unless I say so, unless I tell you very explicitly they are not required. Okay, otherwise whatever I cover are definitely things you need to know. Now the other thing that you guys need to know, in the test or exam, you will be asked about 2 possible kind of questions. Let me just go to, okay, this one here. Okay, look at this part. Properties of a substance. So a substance obviously can be anything, but for your context, it is alcohol, carboxylic acid, or some other thing, maybe a polymer. Now, um, 2 kinds of questions. The first one is they will ask you, what is, give an example or give a physical property for let's say an alcohol. Okay, guys, please, you have to know what is meant by physical properties. Well, obviously, the opposite of physical properties will be chemical properties. Anyway, we'll cover them one at a time. So just be very mindful. These are possible questions. What are physical properties of this blah blah blah? What give an example of a chemical property of this blah blah blah. So if I look at physical properties, now there are a few kinds you can write here. Yes, this is not strictly in your notes because you're expected to know this from your N levels, but I definitely want to revise them here. Perhaps the most well-known physical property will be this one here. Melting point and boiling point. Okay, guys, yeah, please remember, melting point and boiling point are physical properties. Okay, so for example, does a substance has a high melting point? Okay, or a low melting point? For us, typically you won't be asked for that value. What is the exact value? But at the very least, you have to describe qualitatively. Is it a high melting point, high boiling point? Now, guys, I want you to add in, typically, if melting point increases, if melting point is high, it follows that boiling point is high too. Okay, this is almost universally true. Yeah, so just be aware about that. Now, of course, if a substance has a low melting point, let's say methane, then, well, not surprisingly, is typically a gas at room temperature. Okay, so when we talk about this gas, solid or liquid, by default is at room temperature. Of course, if we say that the melting point is high or boiling point is high, let's say for example, butanol. Okay, so I mean, of course, they are relative to each other. So we are comparing methane against butanol. Methane has a low melting point, boiling point. Butanol has a high boiling point, melting point. So, well, again, not surprisingly, it tends to be a solid. Okay, maybe not for butanol, but if you go even higher, maybe I give you a really high one. Hold on. Okay, let's look at this substance. About this one. 300, right? Page 202. Now, if you remember your general formula, this is of course an alkane. And well, I personally, I don't even know the name of it. But at such a with such a big molecule, you would expect a high melting and boiling point, and of course, you would expect it to be a solid. Okay, I think that's all I want to say for now. Let's go to the next physical property. Oh, yes, guys, you may want to fill this in. So that was the first one. Typically melting point and boiling point are taken together. They are hard. Most of the time, they are not separate physical properties. They are considered the same physical property. So try to write something different for the second property. So maybe solubility. Okay. Well, solubility of a substance. Uh, two types. One is in water. Alright, is the substance soluble in water? Now, if it's not, you also need to ask, or what, okay, even if it is, you also have to ask, is that substance soluble in organic solvents? And here I've given you two common examples of organic solvents. One is ethanol, one is acetone. Well, strictly speaking, you may not need to remember them, but just keep them in mind. They may just appear. Okay, so yeah, as I said, there are various substances. Some are soluble in both of this. Some are only soluble in water, but not in organic solvents. And then some are not soluble in water, but soluble in organic solvents. Okay, so that is a physical property. Okay, third one. All right, density. This one is not so commonly used as an answer, but it's still considered a physical property. So you're talking about substance, does it have a low density? And if the density is low, that substance is likely to be a gas. Guys, you're supposed to know this by now. In terms of density, obviously, the highest will be a solid relative to a liquid. And of course, a gas will have the lowest density. So something with high density is likely to be a solid. Okay, so yeah, that is I would say something you should have learned long ago. Okay, there's one which I have erased, but I'll write it in here. So can you add this into your notes if you're writing this down? Oh, questions, anyone? Hopefully I'm not going too fast. But as I said, the link to this whiteboard it was given right at the beginning of this chat box, so you can actually go and look at it yourself. Now let's look at the fourth one. Okay, guys, The other one, fourth one, is quite commonly encountered in your N level. So right, that is your electrical conductivity. Again, hopefully you still remember a bit of stuff. Now, I think the rules are very simple. Applying them may not be so easy, but the rules are still quite simple. So if a substance can produce ions or has free electrons, then that substance can conduct electricity. Okay, so hopefully you notice the keywords: ions, free electrons. All right, these are the charged particles which allow electricity to be conducted. Okay, so electrical conductivity is our fourth physical property. So guys, yeah, I'll repeat. Do remember these few physical properties. But of course, you also have to link them to the correct substance. Alcohol, does it have low or high melting point? Or can it dissolve in water? Can it conduct electricity? Yeah, you're supposed to answer those questions. But anyway, one thing at a time, we'll go through them very soon. The other important question that you're likely to encounter, this one: chemical properties. Your question will ask you, write down one or two chemical properties for, let's say, carboxylic acids. So I'll make it very clear here. Chemical properties refer to chemical reactions. Okay, what are the chemical reactions for, let's say, alcohol or carboxylic acids? Okay, so guys, do remember, might as well do it right now. Chemical properties refer to the chemical reactions a substance can undergo. So let's say for the example of alcohol, okay. Yeah, let me just add it in. Here I'm referring to alcohols, chemical reactions of alcohols. This is straight from your notes. There are only two, okay, maybe two major ones. First is combustion. Second is oxidation. So I repeat, for alcohols, two chemical reactions you have to know, or two types you have to know. One is combustion, one is oxidation. Okay. Okay, but anyway, let's go a bit further into alcohols. Now, let's get a, where's my space here? Yep, here. Okay, let's look at alcohol. All right. Maybe I'll ask some of you. Okay, as I said in class before, you only need to know the first four members. Right? Need to know their names. You need to know the formula. Okay. And names, formula, and of course you need to know how to draw the structure. As I said before, be careful what your question is asking for. Does it want you to write the name, write the formula, or draw the structure? do not give the wrong answer. If they want the structure, writing the name on its own will not give you any marks. Okay, so yes, please be aware of what the question is asking for. All right, let's look at the alcohols. You need to know the first four members. Okay. Yes, Ashria, tell me, what's the first member of the alcohol homologous series?
First member.
Sorry?
Not methanol.
Yes, that's good. Ashria, what's the formula?
Uh, CH3OH.
Yes, excellent. Okay, by the way, everyone is supposed to be able to do all this. Yes, you're supposed to draw the structure too. Now, as I said before, the group OH is typically linked together. Even though you're supposed to realize that obviously it is something like this. Okay, but most of the time you can draw this as OH together. Okay, next one. What's the second member of the alcohol series? Don? Don, go.
Ethanol.
Okay, good. Formula.
C2H4H.
E2H.
C2H5OH.
Yes, good. Yes, I repeat, you're supposed to know the name, formula, and the structure too. Okay, as I said in class, I will leave out the H in the structure, but in your exam or test, you need to draw or add in all the H as well. Okay, third one. Yue. Yue, are you there? Yue. Okay, maybe he or she has gone for a break. All right, who else? Zhuming, you just came in. Group, not group. The third member, what's the name? Zhuming, are you there? Okay. Zhuming, give me the formula as well. Okay, that is fine. Yeah, guys, you're supposed to draw this too. Okay. I just be a bit let's be clear for everyone. Now, I can obviously draw like this too. Let's say for the first one. Okay, for the first one, yeah, it doesn't matter. I can draw this here too. I can draw this here too. But if you want to draw on the left, be a bit careful. Notice I draw it as HO rather than OH. Okay, why is that so? Because you must clearly show that the bond is between O and C. In other words, you cannot draw this. In this case, the meaning is the bond is not between C and H, which is not correct. So be very careful of how you draw. Now, likewise, there are students who drew like this. Okay, and yeah, of course, there are students who drew like this too. Now, you may realize both are wrong. If you look carefully, the link, the way that the student drew it shows the link between C and H, which is not true. Now, same for the next case. If you draw in this manner, the link is between C and H. Again, this is not true. All right, so I mean, I will of course try to correct you along the way, but you must well remember it right now. So be very careful how you draw. The bond is between C and O. C and O. C and O. Okay. Now, likewise for the second drawing, the one of ethanol, yeah, if you want to draw it in this manner, it's perfectly fine. Okay, yeah, it's perfectly fine. It's the same. This and this are the same. And if you want to draw like this, yeah, it's still perfectly fine. You notice that I'm very careful. The bond is always between C and O. Okay, so yeah, small things you may think, but nevertheless they can help you lose marks if you if you draw wrongly. Questions, anyone? No? Okay, then the fourth member. Clarence, fourth member, what's the name? Yes, you might sure give us the formula too. Clarence, formula too. Okay, that's fine. Okay, so yep, he wrote down in the chat box. C9, C4. So yeah, as I said, everyone is supposed to know these four members. Now, of course, in real life, you have other members now the group, now the family. We will not go through them though. So yep, same thing. Please draw your structure correctly. To me, this would be the safest. Oh, how maybe I didn't emphasize it earlier, but let me just quickly tell you how I draw it. First thing first, there are 4 carbons. Okay, C4 or butanol, you know that it starts with but, so it's 4 carbons. So I would normally draw out 4 carbons. You also know that there's an OH group or hydroxy group. Or well, alternatively, you can look at the name. There's a OL. OL stands for alcohol. So OL, and OL. And therefore, I would draw the OH group. Then you fill in the rest of the bonds. Always check carbon has 4 bonds. Now, as I said, in your test or exam, make sure you fill in your hydrogen too. And I think as mentioned last week, hydrogen has only 1 bond. Okay, so check that everything is correct and that gives you your complete structure. Okay, now, questions, anyone? No? So, if not, let's take a look at this propanol. All right, so this was the structure we had earlier. What if I draw this? Same? This do the same?
Yeah, it's fine, it's fine.
Oh, okay. But they said they're the same. What if I draw this? Alright, is this the same
Yeah,
as
it's fine,
this
it's
and
fine.
this? Oh, okay. Okay, guys. Listen up. This one and this one are the same, but this one is not. Because for this one, I can simply just turn it around. Okay? Turn it horizontally around and I will get the same pattern as this. But for this, oh, there's no way you can turn it anyway until you get this one. Okay, or this one. So actually this one is different. No? Okay, anyway, my point is very simple. This guy is still called propanol. This guy also has a formula of C3H7OH. But the structure is different. So I want you guys to be careful about this. And but let me add in something. By default, if your question, exam or test tells you it's propanol, by default, this would be the default structure. Okay? You just need to know in your mind that it can have an alternative structure. But that's not the default one. Okay, so just keep this in mind in case your question is a bit harder this year. So same name, same formula, but different structure. Okay. Likewise for butanol. Look at butanol. Again, be very careful, butanol. This one is even worse. What if I have this? Same thing, I draw the 4 carbons first. Okay, then I add in a OH group here. Look at this. Can you turn it around, sideways, upside down until you get this? Now, maybe you're not used to thinking like this, but the answer is no. No matter how hard you turn this or twist this around, you will never get this guy. But may realize by now, this is still called butanol. Formula is still the same. Structure is different. So just be a bit mindful. Now, likewise, if your questions mentions butanol, and it mentions butanol, so by default, this is the structure by default. However, yes.
Why is it different? In the end, the O is still bonded to the carbon.
Yeah, but it's bonded to the second carbon. Okay, and
Uh,
there's no way you can get this one from this one.
But then it still obeys that carbon still have 4 bonds. Then in the end,
Yeah, it obeys all the rules, just that the structure is different, that's all.
oh, okay.
Well, next time I bring some molecular models for you to play with, and then you try to get this to become this. Okay, you find that it's impossible. Now, just to make things a bit more interesting. Okay, by the way, what I'm doing right now is not exactly very commonly seen in your test and exam, but I still need you to be aware of it in case you face a difficult question. So lastly, what about this? 1, 3, 4. Sorry, 1, 2, 3, 4. Put OH here. Add in the hydrogen. So how? Is this guy the same as this guy? Is this guy the same as this guy? Yes, no?
No?
Mm-hmm. Yep. Correct. It's not. But it's still called butanol. Formula is still the same. But the structure is different from the earlier two. Oh, this one can be important. Yeah, take note, take note. This one can be important. So just take note for now. Okay, so yes, just be careful. Yeah, this guy is called butanol too. Even though that sometimes they add in a bit extra, which I'll tell you very soon. That differentiate this from the other two. Okay, since we're having fun with this, let's go a bit further. How about this? 3, 4. Let's see. One, 3, and 4. Same question, guys. Is this the same thing? So by now you should be a lot savvy.
Should be same thing what? You flip
Same thing.
then the OH still at the same or something. No man?
Same as which one? Same as 1, 2, or 3.
Should be one bah.
1.
Right.
Okay, guys. Yeah, next time you really have to play it with the molecular models. Alright, same thing if you build this model, no matter how you flip around, turn around, twist around, without breaking any bond, without breaking any bond, you never get this one. You will never get this. You will never get this pattern. So, well, by now you should know what I'm going to write next. So yes, this is still called butanol. Alright, formula is still exactly the same, but structure is quite different. Okay, so guys, make sure you jot down in your notes. Have at least 4 different structures for butanol. Okay, butanol, 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 butanol. Now, how about propanol? Propanol is a bit less, so you only have 2 different structures, 1 and 2. Okay, so this is propanol. This is propanol, but they are different. So yes, only 2 possibilities. Questions, anyone? Okay, come, let's go through a bit further. Okay, let's go to this big table here. Yep, yeah, we've done this more or less. Okay, so as I said, you need to know the first 4 members. Met, at, prop, butanol. Need to know their formulas, you need to know their structures. Also, in your mind, be aware that for propanol, there are 2 possible structures. For butanol, there are 4 possible structures. Okay, the other thing that it may be quite obvious, but I thought I'd better tell you. Now, no doubt, since since young, you know that people have consumed alcohols. But guys, be very, very sure. The only alcohol that can be consumed is ethanol. Alright. So yeah, please at least know that so that you don't consume the wrong thing. And think as I said before, ethanol is present in it's the same compound. Wine, beer, whiskey, vodka, whatever, it's still the same ethanol. However, if you look at your notes, they also mention other uses for ethanol. And this has come out in exam quite a few times. Right, name 2 uses for ethanol. So make sure you know besides drinking, nowadays we are pretty I would say familiar with this, hand sanitizers. Ethanol is inside perfume too. it can be used as solvent as well, which I kind of mentioned earlier. So yeah, just be aware there are other uses for ethanol besides for drinking. Can and this is the only one that you can drink. The others are all poisonous. Okay, what else? Maybe you want to jot down your notes, huh? You notice that as I go down the family, from methanol to ethanol to propanol to butanol, MR is increasing. Yeah, guys, you're supposed to know what MR is. Huh? Okay. From here to here, or of course even further down, MR is increasing. Yeah, of course, number of carbons, the number of hydrogens are increasing. Next. I don't know whether it sounds obvious, but the four of them are all liquids at room temperatures. Ethanol is of course a liquid. Yeah, I mean you drink it. Since when have you drunk a gas or a solid? But nevertheless, make sure you know these four are all liquids at room temperature. So that's their states. Okay, their states at room temperature. And may not be obvious, but if they are in their pure form, all four are colorless. Actually, if even you go further down, they'll be colorless too. Yeah, as I said, for the like, let's say you look at beer, wine. How come you have red wine, white wine? How come you have yellow beer? Well, that is not due to ethanol. It's the color is due to other substances. But ethanol, in fact, all the alcohols by themselves, okay, they are colorless. Okay, what else? Remember this? We talked about this earlier. Melting point, boiling point. Okay, guys, this one has definitely come up before in the exam. As it becomes bigger and bigger, okay, from methanol to ethanol, propanol, butanol, basically melting point and boiling point increases. Okay, so take note as you go down the family, MPBP increase. Well, of course, that also means, remember, they are all liquids. That also means as you go down the family, they become harder to vaporize. Yeah, it becomes, yeah, they tend to remain in the liquid state. Now, this part here will not be asked, not exactly, but of course, no harm knowing this, because if you remember your N levels, there's this term called IMF, all right? And what does IMF stand for? IMF. Ashak, are you there?
Yes.
What does IMF stand for? IMF.
No idea.
Oh, okay. Maybe you have left school for too long. Okay, basically IMF stands for intermolecular forces. Okay, it's the attractive force between molecules. So essentially, as you go down the family, from methanol all the way down to butanol and further, intermolecular forces become stronger and stronger. Okay, so it becomes harder to vaporize. That means they also have higher melting points and boiling points. Okay, yeah, that's all I'm going to say. Questions, anyone? Okay, how about this one? Remember, this is also one of the physical property. Oh, this one you have to know. Solubility in water. Can alcohol dissolve in water? Well, the simple answer is yes, especially if, yeah, you look at the alcohol available in the markets. Okay, beer 5%, wine 8%, 10%, 13%. vodka 40%. Yeah, ethanol, the second member can dissolve very well. First one, the first member, this guy, this is methanol. It dissolves even better. But guys, I want you to note down, as you go down the family, it becomes harder and harder to dissolve in water. So
Because got a lot of bond,
solubility
that's why.
decreases. Well, yes, that's one way to look at it, but don't worry, you won't be asked to answer in that manner. But yeah, you're right. Basically, the molecule become bigger and bigger. So yeah, but you have to know, guys, that as you go down the family, solubility in water decreases. Okay, so this decreases, becomes harder to dissolve. So for butanol, this one, the fourth member, butanol is quite hard to dissolve. It's I would say barely soluble in water. So yep, so we have covered. Oh, by the way, state, color, they are considered physical properties too. Okay. MPBP we have already covered. Solubility in water we have covered. What about this? Electrical conductivity. Can they conduct electricity? Have you tried? Alright, running electricity through alcohol. Well, the big answer is no. And the simple reason is they do not produce ions. Okay, there are no charges that can move inside alcohol. So yes, no electricity. So this is another physical property as well. Electrical conductivity. All of them cannot conduct electricity.
So Jay, if I spill alcohol on the floor, then got one wire there, then can I kena electrocute or not?
Hey, but guys, this is only with reference to pure alcohol. But the alcohol you spill, is it pure or not? Or is it mixed with water?
Oh, confirm mix one lah.
Yeah, pure alcohol doesn't come by easily. You can't just buy it in the market, no. Supermarket doesn't provide pure alcohol. You have to buy it from a chemical supplier. Oh, but
Okay,
having
okay.
said that, okay, this is something extra. Last time we used to have this I would say professor. He actually drank this pure alcohol in front of us. No, you just get this pure alcohol, 95%, 96%, and then just squeeze some orange juice inside and then drink it. All right. Well, nothing happened to him immediately. All right. So, yeah, but don't try that. I don't think it's very healthy to drink pure alcohol. Not to mention you can't buy it. All right. He took that from the lab. How about this? Okay, guys, this is important. Flammability. Do alcohols burn? Okay. The simple answer is yes, they do. Okay. And before I go further, just be a bit careful. Flammability means how well something burns in air. Is it a physical property? It's quite controversial. Some people consider it a physical property, but in general, for us, we think of it as a chemical property. Alright, so take note. Flammability is considered, I would say, scientifically speaking, it is considered a chemical property because it involves a chemical reaction. Yeah. And what is the chemical reaction? This one here. Combustion. Oh, by the way, guys, you better learn the word combustion. It means burning in air. So combustion or burning is a chemical reaction. So therefore, we consider it a chemical property. Now, what you need to know. First member, methanol. It will burn the cleanest. But of course, you ask, what is meant by that? Let me write down. Okay, so it means that it has the least soot or smoke. Right. And it tends to have the most complete combustion. Okay, everything is burned off. You hardly have any I would say unburned fuel. Okay, so that is the meaning of cleanness, clean fuel, right? It burns off easily. It burns without smoke, without soot, right? It is completely burned off. You don't have any unburned stuff. But can you guys highlight as you go down the family, then your flammability decreases. It becomes harder and harder to burn. And of course, that also means your burning becomes less clean. Okay. All right. So take that into account. Yes, alcohols can burn, but the one that gives you the best burning, the burn that burns the easiest, should be right at the top, the first member. Okay, this one will burn the most easily. Oh, by the way, the how about the alcohol that you find in a supermarket? Beer, wine, do they even burn?
Huh?
Or,
Will burn meh? If not,
well, I haven't
don't think
answered
so.
my question yet. Well, guys, you can try if you have some money to spare. Just buy a
Cher,
bottle.
vodka burns.
Yes, excellent. Okay, there's an experienced person here.
I've seen it
Okay.
in movies.
You see? Oh, okay. I thought you personally tried it yourself. Okay, guys. Now, I thought this is a question in the exam fund, but obviously, uh, the market alcohol, does it burn or not depends on, probably you know the answer, the percentage. Okay, so if you have something like beer, 5%, forget it. It has so much water inside, it will not burn at normal conditions. Even you have a good quality wine, maybe 10%, also cannot burn. But as our friend here mentioned, beer vodka, 45%. This is good enough to burn. Okay, so I don't think maybe have watched those movies before. Sometimes they want to test, what is the quality of this alcohol? Yeah, then they try burning it. If it burns, then it's good quality. You have a high percentage of alcohol. Okay, typically you need about 30 something percent, right, for burning. So that's the guideline. But this one, no need to remember. It's not exactly something that's going to come out. Okay, questions, anyone? No? Okay, let's go to next part. Questions? No? Yeah, let's go look at burning. As I said, instead of burning, we tend to use the word combustion. So guys, make sure you know what it means. I'm pretty serious because you are supposed to know how to write the equation for combustion. Okay, one other thing, maybe you want to add into your notes. Whenever you have combustion of anything, not just alcohol, but anything like alkane, alkenes, or even hydrogen gas, all of them give out heat. I think it's quite intuitive. You burn something, yeah, you can feel the heat. You can feel the temperature increasing. But I want you to be very aware about this because this may not come out in this particular chapter, but it's something that comes out in another chapter. All right, so all combustion processes gives out heat. Okay, what else? Okay, this is the oh, you're supposed to know how to write the combustion equation. So yes, please pay attention. This is your first one. So let's say I have this. Okay, maybe I erase some of the stuff. So what do you know? So let's say I have my methanol here. Of course, make sure your methanol formula is correct. This is your methanol. And guys, I think we mentioned earlier, the state is liquid. It burns with oxygen. Guys, please do not just write O. Make sure you write O2. Okay, I think too many students have made this mistake in the past. Make sure you write oxygen gas as O2. Yeah, of course it's a gas. Products, yes, you better know. One of them is CO2, which is a gas, obviously. And the other one is H2O. So these are the two products for combustion. At least combustion of organic chemical substances. Now, of course, you may ask, water, isn't that a liquid? Yeah, of course, in general, yes, but don't forget we mentioned this point. We also mentioned earlier, combustion gives out heat. And the heat is so, I would say, strong. The water is in the form of water vapor or even steam. And so that's why it's gaseous over here. Let me see what else. Okay, for the matter, when you burn something, have you ever seen water coming out? I don't think so. Okay, because water is in the form of water vapor or even steam that you can't really see them. Okay, anyway, guys. Oh, you're supposed to balance this. Guys, I hope you haven't forgotten how to do it. But a simple strategy is what I've written there. First step, balance the carbon. There's one here. There's one here. Okay, so carbon is fine. You don't have to do anything about this. Next, you balance your hydrogen. So I have 4 here. Look at the other side. I only have 2, H2. So, well, the simple way to address this imbalance is multiply here by 2. Okay, 4 here, I have 2 here, so just multiply 2, I'll get 4. So make sure you put a big 2 in front. That is your multiply by 2. Next, I check. Oh, guys, try to remember oxygen is the last to balance. How many do I have? 1, 2, and 3. This side, 1, 2, that's 1, 2, and 3, and 4. Remember just now I multiplied by 2, so I will have 2 oxygen here plus the 2 here. So altogether 4 oxygen versus 3 oxygen. So how? Well, the simple way is I write something here. Okay, I multiply something here to the O2. So the easiest way is I just put in a 3 over 2. Now I have 1 plus 3 over 2 times 2, which is 3. So now I have 4 oxygen, which balances my 4 here. So my job is done. Okay, important point. Now, you're no longer in your secondary school, so that also means your coefficients can involve fractions like this. Okay? Yeah, you can have fractions, even decimals. So, yeah, for us, we are open to having fractions and decimals. But let's say you don't like it, well, you can always multiply everything. multiply by 2. Yeah. 1 times 2, you get 2 here. 3 over 2 times 2, you get 3. 1 times 2, you get 2. 2 times 2, you get 4. Okay, then now you have no more fractions. All the coefficients are whole numbers now. Yeah, so if you write in this manner, yes, it's acceptable, of course. But if you put a fraction there, it's acceptable too. Okay, questions, anyone? Okay, yeah. Well, I actually want you to try the other one, but you can. So, guys, can you just try out for propanol, combustion or propanol, how to write out the equation, how to balance the equation. Okay, and in fact, so propanol, first thing, make sure you write the formula correctly. So this is propanol, which you ought to remember. So your question says, write out the equation for combustion of propanol. First thing you need to know, need oxygen, O2 for combustion. And from your notes, an alcohol will produce 2 combustion products. One is CO2, one is water. So guys, this is what I want you to do. Just look at this combustion equation and try to balance it. Shouldn't take too much time. Let's give you 3 minutes. Okay, yeah, you have to do it because this is definitely a very possible exam or test question. And in fact, if you have the time, try doing the same to the other two, ethanol and butanol as well. You need to know how to do for all 4. But of course, I won't be going through all 4. Let's, at least start with this propanol. Make sure you can get it balanced. Okay, time's up. Done? Okay, come. Isaac, are you there? Isaac? Oh, Isaac is still doing it. Tachin, are you there?
Yes.
Come, Tachin, tell me what are the coefficients for each of these compounds. First one, propanol, what's the coefficient? Oh, are you done already?
No,
Oh,
I'm
still
having
doing.
difficulty.
Oh, having difficulty. Okay, guys, tell you what, I'll just go through this. Now, first thing, as I said, if you remember my rules, balance your carbon. Here, how many do I have? On the left-hand side, I have 3. Look at the right-hand side. Oh, I only see 1, which is in CO2, or the C in CO2. Here I have C3. So the simple thing to do is, I just multiply by 3 here. Okay? That will give me 3 carbons. Second thing, balance your hydrogen. Now, as I said, guys, try to remember oxygen is the last thing to balance. So second, balance your hydrogen. How many are there here? I have 7 plus 1, so 8. This one has no hydrogen. How about this side? H2. Well, I only have 2H here. Left-hand side, 8. Right-hand side, 2. So the easy way is multiply by 4. Of course, when I say multiply by 4, you will look at this guy, because only this guy has hydrogen, so you multiply by 4. So now I have H. 8H. Same as left-hand side. Then lastly, as I said, balance your oxygen. How many do I have here? Left-hand side. 1, 2, 3. Hopefully you'll notice that O2 means 2 plus 1 here, so it's altogether 3. How about right-hand side? Remember just now I've multiplied by 3, so it's 3 times 2, I have 10 oxygen. How about this guy? 4. Just now I've added 4 in front, so it's 4 times 4 times 1, so it's 4. Therefore, altogether I have 14 oxygen. Okay, so 14 is a bit troublesome. 3 times 2. Oh, sorry. Sorry guys, I made a mistake. That was 6, not 10. So altogether 10. All right, 3 times 2 is 6. So 6 plus 4 is 10. Okay, so altogether 10 oxygen. Now, I have how many on the left? Only 3. Well, okay, guys, the trick here is you balance your oxygen by adjusting O2. Okay, just do something here. Try not to do something there. Do something here. Okay, so here I have 10. Here I have 3 only. So let's look at here. So I want to, this one I don't touch. So this is 1. So what I do is I touch this side. All right, so the easiest way is just have a 9/2 fraction. Because 9/2 times 2 will give me 9. So 9 plus 1 will give me 10. So now I have 10 oxygen, and on the left, I have 10 on the right. So everyone is balanced and happy. Okay. But of course, like I say, if you are not happy yet, just get the whole thing multiplied by 2. If you are so fixated on whole numbers, and then you get 2C3H7OH plus 9O2. That gives you 62, and 4 times 2 is 8H2. So you can use this answer as well, but as I said, you can also use this answer here with the fraction in front of O2. So this is what your answer should look like. Okay, questions, anyone? Now, as mentioned, you're supposed to know the states. This is a liquid. Remember, the first four alcohols are all liquids. O2 is always a gas. CO2 is always a gas. And as I said, because you have a lot of heat produced in a combustion, therefore, your water is typically vaporized into water vapor or even steam. So this is a gas too. Okay, questions, anyone? Now, I try not to overwhelm you with too many concepts. Let's have one last practice, because seems like some of you are having problems with this. Let's have one last practice. Okay, let's try a more interesting one. Let's say butanol. Okay, come guys, let's work on butanol. First thing, obviously get the formula right. Butanol's formula is C4. But remember, means 4 carbons, right? H2N plus 1. N is 4, so 2N plus 1 is 9. You need oxygen for combustion as always. And when you combust alcohol, you always get CO2 and water. Okay, guys, I want you to work this out. Okay, balance this combustion for butanol and try to follow this. Balance your carbon, followed by hydrogen, lastly, oxygen. Okay, so guys, can you work on this? All right, I'll start the timer. Okay, I repeat, start with carbon first. But for those who have no problems at all with this, writing all these equations out, well, you can just go ahead and write out the equation for combustion of ethanol as well. Because you're expected to know combustion of all four alcohols. Okay, time's up. Let's get somebody. Jie Wei, are you there? Jie Wei. Jie Wei. Oh, out for a break. Jie Wei, are you back already? Jie Wei. Okay, no. Okay, let's see. Nigel, where are you? We have a lot of people meeting. Gerald?
Huh? Yes.
Gerald, tell me what are the coefficients for this equation?
Should be 1, 4, 4, 5.
Okay, let's see. Let me use a different color. 1, 4, 4, 5. Okay, guys. All right, check his answer. Make sure everything balances. Does it look right? Look at this one.
I
How
think
many
it's
oxygen?
1-6.
1-6. Somebody say 1-6. Okay.
Alamak.
Okay, what did Isaac say? Okay, Isaac says 1645. Okay, so this is a new answer. 1645. 1645. Somebody else commented 25810. Wow. Alright. For fun. 25810. Okay, guys, let's quickly do together. Okay, tell you what. Keep your answers. Oh, still another one. Jie Wei is here already. 1645. Okay, so we have quite a few different answers. Okay, guys. Now, if I just quickly run through my method. 1645. That was the last answer. Okay, now, okay, I'm not going to write down everything by now. First step, let me balance my carbon. So I have 4 here. So CO2, I only have 1. So the obvious thing to do is to multiply by 4 here. Next, I look at hydrogen. So carbon is done. Carbon is done. How many do I have over here? 9 plus 1, 10. O2, obviously no hydrogen. How about this side? I have only H2 here. All right, containing hydrogen. So here I have 10. Here I have 2. So I think I would say the obvious thing to do is multiply by 5 there. So 5 times 2, now I have my 10 hydrogen. Okay, so lastly, look at my oxygen. Here I have 4. Remember, whatever you have inserted inside, you still need to account for that. Just now you insert 4 in, you have to account for that too. So 4 times 2 will be 8. 5 times 1 will be 5. So right hand side I have 13 oxygen. How about my left hand side? Oh, left hand side I only have 1 here. Here, okay, let me write clearly. So it's 1 oxygen. Here I have 2. So I would say the simple way is, like I say, ignore this. I'm not saying ignore this. Don't make any change here. All right. Don't make any change here. Make the change here. Okay, so the simple thing to do is I will take 13 minus 1, 12, 12 divided by 2 will give you 6. Okay, so now I have 6 times 2, 12 oxygen. Okay, and of course, all together, 1 plus 12 will give me 13 oxygen, which is the same here. So yes, some of you got it correct. It's basically, now of course you don't have to write 1 here, but I just want to emphasize it. 1, 6, 4, 5. Okay, so this is the final answer. And guys, I repeat, make sure you can add in the state symbols, alcohols, liquid for your syllabus, oxygen, yes, CO2, yes, of course, water. As I said, because of the heat generated, is vaporized, so that would be a gas too. Okay, so guys, I'm not going to go through the last one, ethanol, but I suggest that you do it on your own. Make sure you can balance the last one for ethanol. Questions? Anyone at this point? Nope, all fine. Okay. Like I say, I do not want to overwhelm you with too many concepts, right? Because if I go on further, I will have to introduce a few more new concepts. No, this I'm going to end it here. This basically this whole session has been recorded. The recorded video should be available about half an hour after the meeting has ended. So if you want to watch it again, yeah, feel free to do it. Like I also say, look at your chat box. I have added the link right at the top of the chat box. So in case you want to look at this whiteboard on your own, yeah, you can do so too. But of course, it may be a bit messier because there are other things that I've inserted into this whiteboard. Okay, but your part basically is over here. Right. Last call. Any questions for today? No, all fine. Okay, then if not, I'll see you guys next week. So yeah, that's all for today. Okay, goodbye.
Okay, thanks, Cha. See you.
Yep, see you.
Gotcha.
Bye.